So, good morning, everybody. Today we are going to solve one practice problem, that is 3.2 from third chapter of Fundamentals of Electric Circuits by Alexander Sedicu. So, now we'll solve this. Before solving this, we'll analyze the circuit. The question asked is find the voltages at the three non-reference nodes in the circuit of 3.6. So, this is the electric circuit given. The answer is also given. So first we should know what is a non-reference node, the nodes which other than the grounded ones. Here this is the grounded node. Other than that we have 1, 2, 3. These are not connected directly to the ground. So these are all the non-grounded nodes or non-reference nodes. So we are going to find out the voltage at 1, 2, 3 nodes respectively as V1, V2 and V3. We are going to solve this problem using Kirchhoff's current law. We know that it states that the sum of incoming currents is equal to sum of outgoing currents. And also we have another notation like this. This indicates that it is a dependent current source. So here one Ix current is flowing. Depending on this, you have this dependent current source. Okay, so it is 4Ix. So before going to solve this, we have to name the currents and we have to show the direction of the current flow at all. Already this current Ix and this 4Ix current directions are given. Similarly, the current source 4 amps, that direction is also given, but other things we have to decide. Okay, so we can take this as I1 current. The I1 current enters into this first node and then after that it branches into two currents as I2 current and I3 current. And this I3 current will be flowing through this 2 ohm resistance and enters into this third node. Okay, and at this second node this I2 current is entering, 4Ix current is also entering into the node as given in the problem, and this Ix is leaving the second node. And out of this third node this 4Ix is leaving and this I3 is entering. Similarly we take this I4 current as leaving. Okay, so in this particular node 1 we take the potential as V1. At node 2 it is taken as V2 potential, and at node 3 it is taken as V3 potential. So first let us start with this node 1. So here what are the currents which are entering? I1 current is entering. So it is I1 that is entering, that is equal to the sum of leaving currents, that is I2 and I3. So this I1 current is 4 amps, that is equal to the I2 current can be written using Ohm's law as V1 minus V2 divided by 3 ohms. Plus this I3 can be written as V1 minus V3 divided by that 2 ohm resistance. Okay, so now we can write this as 4, that is equal to, taking common denominator here as 6. So it is 2V1 minus 2V2 plus 3V1 minus 3V3. So you can write this as 24. 24 is equal to 5V1 minus 2V2 minus 3V3. So this is your first equation. 5V1 minus 2V2 minus 3V3, that is equal to 24. This is your first equation. Now we go for node 2. So now we are going to write the equation at node 2. At node 2, if you check, this I2 current is entering. Similarly, this 4Ix is also entering, and this Ix alone is leaving. So I can write this V2 I2 as V1 minus V2 divided by that resistance of 3 ohms plus 4Ix minus Ix, so that becomes 3Ix, that is equal to 0. V1 by 3 minus V2 by 3 plus 3 into, if you check this Ix is nothing but V2, this current can be written as V2 minus 0 divided by 4, right? V2 by 4, that is equal to 0. So if you take the common denominator, then it becomes 12. So it is 4v1 minus 4v2 plus 9v2, that is equal to 0. So I can write this as 4v1 plus 5v2, that is equal to 0. So this is our second equation. This is our node 3. So in this node 3, I3 current is entering, 4ix and I4 are leaving. Okay. So I3 is the current which is entering, that is equal to the sum of currents leaving. Then nothing but 4ix plus this I4 is also leaving. Okay, I4. So this I3 can be written as V1 minus, because it is starting from here and ending at here. So it is V1 minus V3 by 2 ohm resistance through which it is flowing, that is equal to 4 into that Ix. We know already that it is V2 by 4, right? It is V2 by 4 plus I4, it can be written as V3 by 6. Okay, it is V3 by 6. So you get this as V1 by 2 minus V3 by 2. This 4 get cancelled, right? It is minus V2 here minus V3 by 6. I am bringing it to the left hand side, that is equal to 0. So if I take the common denominator as 6, then it is V1 3V1 minus 3V3 minus 6V2 minus V3, that is equal to 0. So I get this as 3V1 minus 6V2 minus 4V3, that is equal to 0. So this is your third equation. So if you check first, second and third, the second equation contains only two variables V1 and V2. But the remaining two contains the node voltages V1, V2, V3. Here also V1, V2, V3. So using this first and third equation, we can eliminate this V3. Okay. This can be eliminated. So to eliminate this V3, here it is 4V3, here it is 3V3. So we can make it as a common as 12V3. For that, this first equation should be multiplied by 4, so that you will get this as 20V1 minus 8V2 minus 12V3, that is equal to 96. And this equation, you can multiply this by 3 to make it 12V3. So this third equation multiplied by 3. Okay. So that you will get this as 9V1 minus 18V2 minus 12V3, that is equal to 0. So now you bring this to this side. So I am going to write this here as 9V1 minus 18V2 minus 12V3, that is equal to 0. So I have brought this to this side. Okay, here. So if you solve this, okay, so make it as minus, this is plus, this is again plus, this is minus. So what happens, this get cancelled. Here you get this as 11V1 and then this is plus 10V2, that is equal to 96. Okay, so I am going to make this as another equation. So now I am going to take this as equation number 4. So now you compare the second equation and the fourth equation. So this contains V1 and V2. This equation, fourth equation contains V1 and V2. Similarly, second equation contains V1 and V2 as node voltages. So in order to eliminate one variable out of this. So in order to eliminate one, we can multiply the second equation by 2. Okay, so that you'll get this as 8v1 plus 10v2, that is equal to 0. So I'll bring this here. So you'll get this as 8v1 plus 10v2, that is equal to 0. So let me take this as fifth equation. So when you solve this, when you take this fourth and fifth equation and change the signs for this, it is minus, this is minus, this is also minus. Okay, so you can cancel these two, and here you will get this as 11 minus 8. So 3v1, that is equal to 96. So 3v1 is equal to 96. Then v1 is equal to 96 by 3, that is 32 volts. So we got one answer now. V1 is equal to 32 volts. Got one answer. This is answer 1. Now this can be substituted in fourth equation, or you can substitute in the second equation. Okay, this V1 can be substituted as 32 in second equation. So equation number second, that is 4V1 plus 5V2, that is equal to 0. This is your second equation. In this equation I substitute this V1 as 32. So it is, so this is 128 plus 5V2 is equal to 0. So 5V2 is equal to minus 128. So V2 is equal to minus 128 divided by 5. So that is equal to minus 25.6 volts. So we got the second answer now. V2 is equal to minus 25.6. Now once you have found out this V1 and V2, you can substitute in any of this equation. So you can go for this third equation, or you can go for the first equation. So we start with the third equation. Okay, so what is third equation? Third equation is 3v1 minus 6v2 minus 4v3, that is equal to 0. In that, 3 into v1 is 3 into 32 volts minus 6 into, this is minus 25.6 minus 4v3, that is equal to 0. So 32 into 3 is 96, minus of minus, that becomes plus, and 25.6 into 6 is 153.6 minus 4v3, that is equal to 0. So when you add this 96 with 153.6, you will get it as 249.6 minus 4v3, that is equal to 0. So 4v3 is equal to minus 4v3 is equal to minus 249.6. So v3 is equal to 249.6 divided by 4. So you get it as 62.4. So this is our last answer, third answer. Okay. So now we'll summarize the answers. So V1 is equal to 32 volts. V2 is equal to minus 25.6 volts. And this V3 is equal to 62.4 volts. So this is the answer we get. Okay. These are the nodal voltages. So now we'll verify the answer. It is given as V1 32, V2 minus 25.6, and V3 is 62.4. So we got the correct answers. Thank you.